So the first question to address today is the concept of LCM. LCM stands for least common multiple. If you're struggling to remember what that means, it means pretty much the exact same thing as LCD, or least common denominator. I mean, the process for finding them is exactly the same. So if I'm given numbers like 4 and 12, and I'm asked to find the LCM or LCD, either one, there are several ways I can approach it. The simplest way, but not necessarily the quickest way of doing it, is to just make lists. So if I start with the 4, and I usually start with the smaller number, and I just start listing out numbers. 4, if I add another 4, it would be 8, add another 4 would be 12. Well, guess what? I can stop right there. Why? Because my other number is 12. So 12 itself is going to be the least common multiple. If I have a little bit more complex problem, let's say I have 6 and 8, I can do the same thing. Start counting up by 6s. 6, 12, what would be next? 18, 24, 30, and I can keep going. But let's go to the 8 now and see if we have to keep going. So it'd be 8, what would be next? 16, 24, and we have a match. 24 is the least common multiple, or least common denominator, between 6 and 8. So if you're struggling with the math and you can't remember the factoring and all that, that will always work to just make those lists and see what matches up.
So that's how you find the least common multiple.
That's how you find the least common multiple.
All right.
Now, if you want to do a more organized way of doing it, rather than just making lists, we could go to the factoring. Like back to this one, 4 and 12. If I factor a 4, 4 is just going to be 2 times 2. If I factor a 12, if I do out the factor tree, it comes out to be 2 times 2 times 3. So I look at these. They both have a 2. They both have another 2. This one, however, has an extra 3. So I have to multiply the top number by a 3. I have to add a factor of 3 in there. So 4 times 3 is 12. That's a more organized way of doing it. It's a little more confusing? Okay. Oh yeah, you can always make lists. That always works out. If you get to bigger numbers, though, the lists can be kind of frustrating. Let's do the 6 and 8 here by factoring. So 6 factors to 2 times 3. 8 is 2 times 2 times 2. So now they both have a 2 in common. This one has a 3 that the other one doesn't. So I need a 3 down here. So now we've got the 3 in common. This one has 2 extra 2s, so we need 2 more 2s up here. Now they are the same. So if I multiply this back up, I get 24. Multiply these back together, I also get 24. That's good because I need those to match up. So, that's factoring, yes. Okay, let's do it with some bigger numbers. Let's actually take a look and see. I know they had some really ugly ones here in the homework. 27 and 99, that would be a good one. 27 and 99, it would get really frustrating if I tried to make lists. Really frustrating. So 27, I'm going to factor it. 3 times 9, 3 times 3. So 27 is just 3 times 3 times 3. 99 will factor. That'll be 9 times 11. 11 is prime. 9 is 3 times 3. So it's 3 times 3 times 11. So what do they have in common? Well, they have a 3. They have another 3. This one, however, has an extra 3 that the bottom one doesn't, so I need to put that extra 3 in there. Now those are good. The bottom one has the extra 11 that the top one doesn't, so I have to put an 11 up there. Now we're good. If I multiply these back up, 3 times 3 is 9, times 3 is 27, times 11 is 297. 3 times 3 is 9, times 11 is 99, times 3 is 297. So 297 is the least common multiple of those. Or 14 and 105. Try something like that. Actually, you know what? I am going to pause the recording right now and let you guys try that one and see how you do. So 14 factors into 2 times 7. 105 factors into 3 times 5 times 7, correct? So if we look at what they have in common, all they have is the 7. Well, the top one has a 2 that the bottom one needs, so we multiply by 2, so that's good now. The bottom one has the 3 and the 5, so we've got to multiply the top number by 3 and 5. Now we're good there. Multiply that all out, both of those come out to be 210. What's that? 420 would work, it's just bigger than you need. Yeah, it's not the smallest. Let's give you another one to try. Let's say you try 84 and 105. See what you come up with. 84 factors into what? What's that?
How do you get that?
Okay. Actually, 2, 2, 3, and 7. So with 84. 84 can be divided by 2. So I'd be left with 42, right? It's even. So you divide by 2 and you're left with 42. You divide by 2 again. 42 divided by 2 would be 21. Well, you can't divide by 2 anymore. But you can divide by 3. That'll leave you with 7. Those are all primes. That's 2, 2, 3, 7. Next, 105 becomes... Yeah. Okay, let's do that. 105. It ends in a 5, so we know it's divisible by 5, right? So if you divide it by 5, you're left with 21. 21 is just 3 times 7. So 3, 5, 7. Okay. So they've got a 3 in common, and they have a 7 in common. This one has 2 extra 2s, so we need 2 more 2s down here. This one has the 5, so we need a 5 up here. So that's 420. I figured I'd come up with a problem that agreed with your answer so you could shut up.
Oh, you're nice. No.
Sorry.
Why don't you just, because that other way just gives me a headache, why don't you just keep
Make
taking
this
the
list?
105
Yep.
times like 1 times 2, whatever, and then divide it by
You can do that. You can just, until it divides out evenly. You
Yeah.
could, but it takes a lot of calculator work.
Well, that's better than
And you can just sit there 84, 168,
No, but you go with bigger
252, or 105, 210, 315, 420.
I was thinking, since it's 84,
Mm-hmm.
it would have to end in, like 20 or something like that.
It doesn't have to. Just that, it has to end in an even number, so it can't be 315 can't work.
Well, it couldn't, it couldn't end up,
Could end in a 5, because 4
it
won't
couldn't
go
end
in.
up in a 3, you know
Yeah.
what I'm saying?
Yeah, it has to end in an even number, you know that.
Right.
Today's the 19th. Let's try a couple more. Let's see here. Let's do 42 and 66. Have you try those? Let's just take a look at your factoring. What did you get for factors of 42? 237. Good. 66. 2, 3, 11. No 7. But you'll have to put a 7 eventually. Yeah. Okay. Yeah, in common, they both have the 2 and the 3. This one has a 7. This one needs a 7. This one has the 11. This one needs the 11. That should now multiply up to 462 for each of them. Imagine that. Yeah. Sorry. We might have something like this. Find the least common multiple.
First we already have 2, 3, and 7. And since we already have a 3, we don't put a 6 on there by adding 2 3s. Since it's already 3.
It should be just 2, 3, and 7. Is all it should be.
I heard you say that, but then I got the 3 and 3 because I was thinking 7 and 6 is 42.
Okay,
So,
what you do, you got 7 and 6, right? The 7's prime, so you circle it. But then the 6 gets split up into 2 times 3, so the 6 is gone.
so the 6 is already there, so
Yeah,
that 3 and
yeah.
3 wasn't, okay.
Yeah, so there's just 1 3 in it. Yeah.
This is the stuff I have problems.
When you add in the variables,
Yeah.
I'll give you a hint. Ignore the variables. Find the least common multiple for just the numbers. So the hint I gave you was to ignore the variables and just deal with the numbers. So if we factor 66, it is 2 times 3 times 11. If we factor 110, it's 2 times 5 times 11. If we were to throw the variables in, x squared is just x times x. And of course, x is just x. So what do we have in common? We have a 2, we have an 11, and we have an x. On top, we have a 3 that we need down here. We also have another x that we need down here. Bottom, we have a 5 that we need up here. So multiplying this all back together gives us 330x squared. Down here, multiplying that together also gives us 330x squared. Because there's 2 x's. There's an x and an x. There's an x here. We did another x. Yep. When we're dealing with least common multiples with variables, it's always the highest power of the variable. For example, let's do 6x squared y to the 5th z and 8 x to the 3rd y to the 3rd z to the 3rd. We can separate this out like we did all of our fractions that had variables in them. Just look at the numbers. I'm not going to do factors or anything here because between 6 and 8 we can figure out what the least common multiple is. It's going to be, what is it? 24. Very good. So we found the least common multiple for the numbers for 6 and 8. 24. Now for the variables, we don't need to list them out because we know that for each variable, it's just going to be the highest power. So for x, it will be the 3rd, 2 and 3, so use the bigger one, 3. Y will be the 5th, and z to the 3rd. There it is. Not so bad.
Can you leave it there for just a minute?
Yep, I can leave it there for a minute. You guys try that one. So let's take a look. Now for the numbers, I'm still going to factor. Just get the numbers. 12 is 2 times 2 times 3. 28 is 2 times 2 times 7. So we have a 2 and a 2 in common. Here's a 3, so we need a 3 down here. There's a 7, we need a 7 up there. So it looks like 84 is going to be the number that's our common, least common multiple. 84, x to the 5th, y to the 4th. Very good. Let's try one more of these. Try that one. Okay, so 30 and 75, what do we get? What's the number? 150. Good. A to the third, B to the third, C to the third. Anybody not get that? We're good? Cool. Well, then the next step would be to apply this to something that looks like this. So looking at something like this, what would we do to add those fractions? We need a common denominator. We need the same name. So all that's asking us to do is to take these and find a LCM, least common multiple. So I'm going to have you first start by finding the least common multiple of those, and then we're going to look at how do we go from there. So this one I'm actually going to set up as factors just because when I factor these, it gives me a blueprint for how to do the fractions. So, for example, the 14a squared was 2 times 7 times a times a. 35a squared is 5 times 7 times a. They both have a 7 and an a. This bottom one needs a 2 and another a. Right? The top one needs a 5. Now let's keep this stuff in red here in mind now as we go back to the fractions. 3 over 14a squared and 6 over 35a. We've determined that our common denominator is going to be 70a squared. How do we get to that? Well, it's right here. To make the 14a squared into a 70a squared, what's in red here? We had to multiply by 5. We had to multiply the 3 by 5 to get 15. What do we have to do to turn the 35a? Well, right here. The 35a, we had to multiply by a 2a. So 6 times 2a is 12a. So now when we go to combine, we have the same name. We're going to keep that same name of 70a squared. 15 plus 12a is 15 plus 12a.
Oh, I did it again. I always want to add that.
You always want to make it 27a?
I do.
Yeah, you can't do that. They have different names. You can't actually add them.
Right.
Let's try. Try this one. See what you come up with. What do we get for common denominator? 24. What? A to the third. Good.
Are we subtracting?
What's that?
I didn't realize you were subtracting.
Okay. What do we have to multiply this by to turn it into a 24 a to the third? Well, to change the 8 into 24, we multiply by 3. It's already a to the third, so we don't have to do anything with that. So times 3 here is 21. Turn a 12 into a 24, we multiply by 2. 12 times 2 makes 24. Then for the a squared, to make it an a to the third, we multiply by a. So 2a we multiply by. So 5 times 2a is 10a. And now we're subtracting. So we're going to keep the same name, 24a to the third. And then 21 minus 10a is 21 minus 10a.
I got it.
Cool.
Well, kind of, except for the little minus.
Sure. Questions? Okay. Are you okay finding the least common multiple? If I give you the 8, do you put the variables in? Okay. Well, then let's look at that. Let's just As I said, the way to do is just ignore the variables. Ignore a to the third and a squared completely. What's the least common multiple of 8 and 12?
Oh, wait.
24. So you get the 24. Then you come back and you look at the variables. What's the highest power? 3. So that's just going to be 8 and the third. So the variables, when the variables come into it, all you have to do is find the highest power of each variable, and that's going to be in the least common multiple. So let's say we have, let's see here, 36 x to the fifth y squared and 30 x to the fourth z. And I want to find the least common multiple. I'm going to do the 36 and the 30 and find the least common multiple for those numbers first. So 36 and 30. 36 is 2 times 2 times 3 times 3. Are you okay doing the factor tree to get the factors? Okay. 30 then is 2 times 3 times 5. So now we have 2 in common and a 3 in common. This one has a 2 and a 3, so this one needs the extra 2 and 3. This has the extra 5, so this needs the extra 5. Gives us 180. So the 180 is the number for the least common multiple. So coming back up to what we're doing here, we know we have 180 x to the fifth, y to the second, because there's no other y, and is that it? Still need the z. And that's it. Okay, so now let's go back to the fractions. Something like this. Okay. So again, we're ignoring the variables for now. 15 and 25. With a little bit of work, you're going to find 75 is the common denominator, or common multiple, whatever. And it'll be x to the second, x squared. Okay. So we found the common denominator right now. That is our first step. So now I'm going to set these up over here. 2 over 15x, 3 over 25x squared. We're adding. I know my common denominator is 75 x squared. So now what I have to do is I'm just going to look at the numbers first. 15 to 75. What do I have to multiply it by? Well, 75 divided by 15 is 5. Now, that's the easier part. The harder part is what's coming right now. Does the variable match up? It's x, but I need x squared, doesn't it? How do I turn an x into an x squared? I have to multiply by another x. That's the part that's confusing you right there, isn't it? Okay. Or you think, what's x squared divided by x? Just x, right? Because 2 minus 1. So I have to multiply by that x. So on top, I have to multiply by 5x. 2 times 5 is 10x. Down here, I'm going to do the same thing. Look at the number first. How do I turn a 25 into a 75? Multiply by 3. Or 75 divided by 25 is 3. Look at the variables. X squared divided by x squared cancels out. There's nothing there, so I don't have to multiply by the by the variable at all. So I'm just multiplying by the 3. So times 3 here is 9. So now we keep the same name, 75x squared. 10x plus 9 is 10x plus 9. And that's it. What do you think?
I add those together.
I'm most on the subtracting fraction thing.
Okay. Subtracting really doesn't change anything. Well, the powers?
Subtracting with the powers, that's what I don't understand.
Okay.
Is that the same as with adding
Yep.
the powers?
Yeah.
Just subtract the powers?
Exactly. Yeah, 10 squared, or x squared divided by x, 2 minus 1 is 1. So it's just another x to the 1 or x that I have to multiply by. Well, I think I've done as much damage as I can for a day there. I'm going to turn you guys loose to practice these. So try to get to the quiz if we can.